Hi friends, welcome back to my YouTube channel. So today I am going to discuss about TDMA, time division multiple access. So as you know, I have already discussed about the introduction part of multiple access and then frequency division multiple access, and now we are going to discuss about TDMA, time division multiple access. So there are major multiple access techniques are available like TDMA, FDMA and CDMA. So this is from the topic Advanced Communication System EC407 for Electronics and Communication Engineering students from BTECH from the module 6 part. So let's go to the video. So TDMA means time division multiple access. A system divides the radio spectrum into time slot. So as you know, the frequency division multiple access, the spectrum is divided into different frequency slots. So here it is divided to time slots, and each slot is only one user is allowed to either transmit or receive. So here also one time slot is only for one user to allow either transmit or receive. So it can be seen that from the figure that each user occupies a cyclically repeating time slots. So a channel may be thought as a particular time slot that reoccurs every frame, where n time slots comprise a frame. So here you can see channel 1 to channel n. So 1 to n channels are available, and these are the time slots available, and each user can allocate one channel at a time to transmit or receive, and this will continue cyclically. So once the user is once used for transmitting, and another cycle it will come after n times. So in TDMA system, transmit data in a buffer and base method. Thus the transmission for any user is non-continuous. So here, like I said, it is cyclically rotated for each user. So the transmission is non-continuous and they transmit data in a buffer and base method. So this implies that unlike in FDMA system, which accommodate analog FM, and digital data and digital modulation must be used with TDMA. So because of these non-continuous and buffer and based method, in FDMA system which accommodate analog FM and digital data and digital modulation must be used with TDMA. So due to this, we need to use the analog FM and digital data and digital modulation in TDMA. It can be seen that a frame consists of number of time slots, and each frame is made up of preamble and information message and trail bits. So you can see each frame consists of number of time slots. So these time slot or each frame is made up of preamble and information message and then tail bits. So in TDMA TDD, half of the time slots in the time frame information message would be used for the forward link channel, and half would be used for reverse channel. So the transmission from various users to interlaced into a repeating frame structure as shown in figure. So one TDMA frame, you can see there is a preamble and then information message and then trail bits. So in slot 1, in information message they have slot 1 to slot n, and after that one slot is divided into trail bits, synchronization bit and then information bits and guard bits. So this is a structure of one TDMA frame. So TDMA scheme where each channel occupies a cyclically repeating time slots. So in TDMA FTD system, so before we talked about TDMA TDD system, and here we are talking about in TDMA FTD system, an identical or similar frame structure would be used solely for either forward or reverse transmission, but the carrier frequency would be different for the forwards and reverse link. So in frequency division duplexing, in TDMA we are using different frequencies for forward and reverse link. In general, TDMA FTD system intentionally induce several time slots of delay between the forward and reverse time slots of a particular user, so the duplexer are not required in the subscriber unit. So if we are using FTD in TDMA system, it does not require duplexer, since it reduces the time slots delay between the forward and reverse time slots. So that's way we can reduce the complexity in the system and also the cost of the system. And in a TDMA frame, the preamble contains the address and synchronization information that both the base station and the subscriber use to identify each other. So guard times are utilized to allow synchronization of the receiver between different slots and frames. So different TDMA wireless standards have different TDMA frame structure. So for the exam you can mention these information, and don't forget to draw this figure. This is very important, and if you are not able to draw this figure, you will not get the maximum score from the exam. So try to add this figure also, and also try to add this preamble or TDMA frame also. So now we can discuss about TDMA features. So TDMA shares a single carrier frequency with several users, where each users make use of non-overlapping time slots. The number of time slots per time frame depends on several factors such as modulation technique, available bandwidth, etc. So data transmission for users of TDMA system is not continuous but occurs in bursts. So this is a result of low battery consumption, since the subscriber transmitter can be turned off when not in use. So which is the most of the time. It's the case of the most of the time. So the third one is because of the discontinuous transmission in TDMA, the handoff process is much simpler for a subscriber unit, since it is able to listen for other base station during idle time slots. The fourth one is an enhanced link control, such as that provided by mobile assisted handoff, that MAHO, can be carried out by a subscriber by listening on an ideal time slot in the TDMA frame. And the fifth one is TDMA uses different time slots for transmission and reception. Thus duplexer are not required. Even in FTD is used a switcher rather than a duplexer inside the subscriber unit is that are required to switch between transmitter and receiver in TDMA. In the adaptive equalization is usually necessary in TDMA system, since the transmission rates are generally very high and compared to FDMA channel. And in TDMA, the guard times should be minimized if the transmitter signal at the edge of the time slots are suppressed sharply in order to shorten the guard time. The transmitter spectrum will expand and cause interference to adjacent channel. So this will cause an interference to the adjacent channel, since the guard time should be minimized and the transmitter signal at the edge of the time slots are suppressed sharply in order to shorten the guard time, and this will cause the spectrum to expand and cause interference to the adjacent channel. And the high synchronization overhead is required in TDMA system because of the base transmission, and TDMA transmissions are slotted and thus requires the and received to be synchronized for the each database. In addition, guard slots are necessary to separate users, and this result in the TDMA system having larger overhead as compared to FDMA. So TDMA system having larger overhead compared to FDMA. And the last feature of TDMA is that TDMA has an advantage is that it is possible to allocate different number of time slots per frame to different users. Thus bandwidth can be supplied on demand to different users by concatenating or reassigning time slot based on priority. So these are all the features of TDMA. So efficiency of TDMA, this is not important, but I will tell you what the efficiency of TDMA in a simple manner. So efficiency of TDMA system is a measure of the percentage of transmitted data that contains information as opposed to providing overhead for the access key. The frame efficiency is the percentage of bits per frame which contains transmitted data. So note that the transmitted data may include source and channel coding bit. So the raw end user efficiency of a system is generally less than the frame efficiency. So this is not important, you can ignore this part. Number of channels in TDMA system. This may be asked in questions. This is the problem that can be asked in the exam. So you can, if the simple equation is there, n equal to m into b dot minus 2 b guard by bc. So the number of TDMA channel slots that can be provided in a TDMA system is found by multiplying the number of TDMA slots per channel by the number of channels available, and is given by n equal to m into b dot minus 2b guard by bc. So where m is the maximum number of TDMA users supported on each radio channel. And note that the two guard bands, one at the low end of the allocated frequency band and one at the high end, are required to ensure that the users at the edge of the band do not bleed over into the adjacent radio service. So this equation you can remember, and we will discuss two examples for the equation. So first example, consider a global system for mobile which is a TDMA FDD system that uses 25 MHz for forward link, which is broken into a radio channel of 200 kHz. If 8 speech channels are supported on a single radio channel, and if no guard band is assumed, find the number of simultaneous users that can be accommodated in GSM. So the thing is that we need to find the number of channels accommodated in GSM. So the equation you can use m into b dot 2 minus 2b guard divided by bc. So you can apply that that difference between those high and that thing by 25 megahertz divided by 200 kilohertz by divided by 8 equal to 1000. So in GSM can accommodate 1000 simultaneous users. And second example, if GSM uses a frame structure where each frame consists of 8 slots and each time slot contains 125.25 bits and data is transmitted at 270.833 kb per second in the channel. Find A, the time duration of the bit, and the time duration of slot, and the time duration of the frame, and how long must a user occupying a single time slot must wait between two simultaneous transmission. So the time duration of a bit TB can be found at 1 by 270.288 kb per second, and time duration of the slot T slot can be found out 156.25 into TB. So TB is 3.692 microsecond equal to 0.577 millisecond, and the time duration of a frame TF equal to 8 into 8 time slots are there, so 8 into T slot. T slot is 0.577 millisecond, so we will get 4.615 millisecond. And the fourth one, a user has to wait 4.1615 millisecond, the arrival time of a new frame for its next transmission. So this is the two examples that I can share with you for the equation, that is for the number of channels available in TDMA. So this is all about TDMA system, and I have discussed the features of TDMA and what is TDMA, and then pictures, I mean the graphical representation of TDMA system, TDMA frames, and then the efficiency of TDMA, and two examples. So that is all about today's section, and if you like this video, please subscribe my channel, like, share and comment. So if you have any doubts, please let me know and put the same in the comment box, and I will definitely give an guidance. And yeah, see you in the next video. Thank you.